There's a small problem with the type checker as I presented it so far. And the way we can talk about that problem is to point out that the type system is not sound. Type soundness is how we make sure a type system is okay. A type soundness theorem says that if you have an expression, and if the type checker claims it has a particular type, as a top-level expression, starting out with the empty environment, then when you run E, you never get an error. That is what we want our type system to do, and so we can phrase it as a theorem of this form. Now, in reality, this theorem is a little bit too strong for most languages because if we add divide by 0, other errors like that might be okay. So a type soundness theorem might say if you have a type for an expression E, then you run it and you only get divide by 0 errors, no other kind of errors. So what soundness does is, what your type checker should do, is rule out all but a certain class of runtime errors, and we can write as a theorem the fact that that happens. If soundness doesn't hold, if this theorem can't be proved, then that means you have a bug on the type checker somewhere, probably. Right? So in this case, letrec checking actually has a bug depending on how you define soundness, because here I've declared f to have type num arrow num. So when I refer to f, well, that has type num arrow num, which is consistent with the declared type, and then I could apply it to 10, and it looks like I would get a number back. But if we run this, then we will get a use before initialization error. So one solution is to change the grammar to force there to be a lambda on the left-hand side, on the right-hand side, and then you can never get an error. You can never use a variable too early, and that is actually a kind of choice that some languages make. Another choice is to adjust the soundness theorem and say that use before initialization, that's one of the errors that are still possible even after you type check. So both of these are reasonable, practical, and realistic choices to addressing the soundness problem. In the second case, we're just reducing our expectations a little bit. There's a more serious problem with let type, and I need a bigger example to explain that. So here I have defined a let type foo, and then I have a function that wants a foo, and it does good things with that foo, right? It type cases on x. If it's the A variant, it returns a number. If it's a B variant, it returns a number. Then it adds 1 to that. All good. Here I've defined foo again, and this local context, foo, means something else. A has a function inside of it, and B just has a number. So what I'm doing now is returning a variant constructed by A. As far as this let type is concerned, the result type is foo, because that's what I'm returning. I'm returning an A, which is a variant of the foo type. And this let type here returns this function, which wants a foo. So as far as the type system can see right now, it's okay to apply this function, which wants a foo, to this argument, which is a foo. But of course the problem is that when we take this A and we pull out the end field, it's actually a function, and then we try to add 1 to a function, and things go wrong. Right. So what is it that went wrong here? It's that we had two different notions of foo as local types, and this local name kind of flowed into this other context in a bad way. So we could avoid that if we just didn't have let types. If we put all of our type definitions at the top, we'd define type and complained if there was multiple declarations. There's another choice, a more general choice, is that we don't let D escape from the let type. Right? The problem here was that we claimed this expression had type foo, but foo had no meaning from the outside. So the solution is to just not let D, in this case foo, be mentioned as the result type of this let type expression. And we can fix our let type form by adding exactly that constraint right here. The result, the type of the body is tal0, so that's the type of the let type, but add an extra constraint that says that tal0 doesn't mention D anywhere. And then this expression would be rejected. We wouldn't mix up the two different foos.